Automated hiring platforms often fail because they operate as black boxes, ingesting candidate data and producing an instant, unexplainable decision. These legacy systems rely on binary logic. A candidate either passes or fails, leaving the hiring team with no visibility into the specific variables that drove the outcome. For an enterprise, this opacity creates significant liability. It introduces untraceable bias, it destroys auditability, and fails strict compliance standards. IntegrityLens restricts the software to generating signals. The architecture ensures the system is never the final decision maker. Providing structured, human-readable evidence is the only way to preserve legal defensibility and accuracy at scale. To build this evidence, the system eliminates static, point-in-time interview checkpoints in favor of continuous telemetry. Throughout the hiring lifecycle, the platform ingests thousands of discrete data points across biometrics, technical inputs, and environmental metadata. The system captures 4 distinct streams: identity verification, interview transcripts, technical assessment inputs, and reviewer metadata. These disparate streams are continuously correlated, synthesizing into an immutable record called an evidence model. This architecture changes the AI's role from an autonomous manager to a precise forensic investigator. Remote hiring requires capturing asynchronous, high-frequency data without compromising identity integrity or allowing environment spoofing. The logic begins as the candidate enters the pipeline, creating a company-scoped record. The system assigns a unique alphanumeric token, acting as the identifier anchoring every data point. This token is written into durable Firestore state, establishing the root for future data routing. A state-driven workflow prevents impersonators from injecting spoofed metadata or switching devices mid-interview without breaking the chain of custody. Establishing a token-anchored candidate record is a prerequisite for any audit-ready enterprise workflow. With the state anchored, the first layer of ingestion begins, proving the remote candidate is who they claim to be before the assessment starts. For government IDs, optical character recognition targets the machine-readable zone, extracting raw data text. An extracted facial wireframe is mathematically compared against the live webcam feed using TensorFlow. The document, face, and voice confidence scores route as discrete signals back to the central token. By isolating biometric confidence into separate data streams, the system neutralizes single-point failures and makes deepfakes difficult to sustain. During the technical assessment phase, the system shifts to monitoring behavioral telemetry in real time. The Angular 21 frontend silently observes and logs environmental anomalies on the candidate's machine. It captures specific browser integrity events, tab switches, blur events, context menu usage, and developer tool shortcuts. For software roles, the platform uses a Monaco editor integration to natively capture complex coding assessments. The editor logs every test run, every execution error, and provides a precise playback of the candidate's keystroke pacing. This high-frequency data is streamed via RxJS directly into Firebase as strict, time-stamped event arrays. Capturing this level of technical detail makes AI-assisted cheating visible within the telemetry log. Hybrid hiring requires a final telemetry layer, orchestrating live, multi-participant video interviews. Deep backend integrations with Zoom and Teams SDKs allow the platform to continuously extract meeting metadata during the call. The system tracks screen share initiations, specific participant logs, and audio or video dropout anomalies. Simultaneously, OpenAI and Whisper models process the live audio feed into structured, queryable text transcripts. The Express 5 backend aggregates this metadata and the AI transcript into a unified packet routed to the candidate record. Synchronizing live video metadata with transcripts removes the blind spots historically found in remote interview integrity. This underlying architecture exists to surface a massive data payload to the hiring team. The telemetry is aggregated into a centralized dashboard that categorizes the biometric, code, and browser evidence into readable visualizations. The AI is restricted to generating advisory labels, such as hire, hold, or reject. These labels are linked to the underlying raw evidence, forcing the reviewer to see exactly why a flag was raised. The final hiring disposition requires manual input by a human reviewer. This strict separation between automated signal generation and human disposition guarantees enterprise GDPR and SOC 2 defensibility. Implementing this level of multi-layered telemetry from scratch involves significant engineering costs. A custom build typically costs between $1.6 and $2.5 million and takes up to 18 months of development. The IntegrityLens in-house clone provides the complete source code for $450,000. This entirely on self-hosted infrastructure. It eliminates per-candidate SaaS fees and allows for infinite customization of the Angular and Express stack. Purchasing the source code allows an enterprise to secure data sovereignty and bypass 18 months of platform development.